The speed of cars passing through an intersection varies from 2 to 32 miles per hour. The speed is uniformly distributed, so they just told me that this is a uniform distribution problem. So I am going to define the continuous random variable x follows uniform distribution. The minimum is 2, the maximum is 32. So we are saying that the minimum is 2, and then the maximum is 32, and then x is between 2 and 32. All right, and then what else? And then we can find the probability density function that is f of x equals to 1 over the maximum minus the minimum, and then the PDF is 1 over 30. PDF represents probability density function, and then x is between 2 and 32. And then regarding the graph, let's sketch an x and y axis. So this is my y axis, and then this is my x axis. This is x, and then this is a y, and then the x is from where to where? The x is from 2 to 32. I do want to keep this line straight. Okay, 2 and 32. So 2 is here, 32 is over there, and then we have a horizontal line that goes from 2 to 32. And then this mark is 1 over 30, and then this is a 2, this is a 32, so that looks like a triangle. The dashed line is not part of the graph. And then f of x is equals to 1 over 30. I have a horizontal line that lives between 2 and 32, and then the height of this rectangle is 1 over 30. How do I know that this is a valid probability density function? Easy. You have to show that the area of this rectangle is equals to 1, and then area is equals to base. Base is 32 minus 2 times height 1 over 30. 30 times 1 over 30, that is equals to 1. So the area under the graph from 2 to 32 is equals to 1. And then what else can we get? We can find the expected value. This is a uniform distribution. Then the formula is a plus b divided by 2. A plus b divided by 2, and then you just add them. You know what? I would like to say expected value of random variable x that is equals to a plus b divided by 2, which is 2 plus 32 divided by 2, and then the expected value is equals to 17 miles per hour. 17 miles per hour. So using one word, I can say on average, the cars passing through this intersection at 17 miles per hour. And then the variance of x, according to the formula, this is a 1 over 12. This fraction is always 1 over 12 in all uniform distribution problem, and then multiply b minus a squared, which is 1 over 12, 32 minus 2 squared. We have 30 squared divided by 12. You have 75 miles per hour squared, because you square the mph. That's why the unit is in square. Can we square miles per hour? No, we cannot. That's why the variance is meaningless. And then to compute the standard deviation, SD of x, you have to take the square root of the variance, and then this is approximately equals to 8.7 miles per hour. And then how do we use the 17 and the 8.7? You can take a 17 and then plus or minus 8.7 to create an interval estimate. The 17, you are using one number to describe the average speed, and then you plus or minus the standard deviation, and then you have 8.3 miles per hour, comma, 25.7 miles per hour. So instead of saying cars passing through the intersection at 17 miles per hour, I can be more flexible, saying that the car passing through the intersection at a speed between 8.3 and 25.7 miles per hour. So that provides an interval estimate. And then this is pretty much the setup for a uniform distribution problem using those two numbers, 2 and 32, and then a random variable x. You can do all of this. And then the next step is we can jump into some basic probability questions. So let's say a car passes through this intersection. What is the probability that the speed is all at most 20 miles per hour, or you can say at least 28 miles per hour for this? Let's do that in the next video.